In computer science, a queue is a particular kind of abstract data type or collection in which the entities in the collection are kept in order and the principal operations on the collection are the addition of entities to the rear terminal position, known as enqueue, and removal of entities from the front terminal position, known as dequeue. This makes the queue a first-in first-out data structure. In a FIFO data structure, the first element added to the queue will be the first one to be removed. This is equivalent to the requirement that once a new element is added, all elements that were added before have to be removed before the new element can be removed. Often a peek or front operation is also entered, returning the value of the front element without dequeuing it. A queue is an example of a linear data structure, or more abstractly a sequential collection. Queues provide services in computer science, transport, and operations research where various entities such as data, objects, persons, or events are stored and held to be processed later. In these contexts, the queue performs the function of a buffer. Queues are common in computer programs, where they are implemented as data structures coupled with access routines, as an abstract data structure or in object-oriented languages as classes. Common implementations are circular buffers and linked lists. Queue implementation, theoretically, one characteristic of a queue is that it does not have a specific capacity. Regardless of how many elements are already contained, a new element can always be added. It can also be empty, at which point removing an element will be impossible until a new element has been added again. Fixed-length arrays are limited in capacity, but it is not true that items need to be copied towards the head of the queue. The simple trick of turning the array into a closed circle and letting the head and tail drift around endlessly in that circle makes it unnecessary to ever move items stored in the array. If n is the size of the array, then computing indices modulo n will turn the array into a circle. This is still the conceptually simplest way to construct a queue in a high-level language, but it does admittedly slow things down a little, because the array indices must be compared to 0 and the array size, which is comparable to the time taken to check whether an array index is out of bounds, which some languages do, but this will certainly be the method of choice for a quick and dirty implementation, or for any high-level language that does not have pointer syntax. The array size must be declared ahead of time, but some implementations simply double the declared array size when overflow occurs. Most modern languages with objects or pointers can implement or come with libraries for dynamic lists. Such data structures may have not specified fixed capacity limit besides memory constraints. Queue overflow results from trying to add an element onto a full queue, and queue underflow happens when trying to remove an element from an empty queue. A bounded queue is a queue limited to a fixed number of items. There are several efficient implementations of FIFO queues. An efficient implementation is one that can perform the operations enqueuing and dequeuing in 1 time. Linked list, linked list has 1 insertion and deletion at both ends, so is a natural choice for queues. A regular singly linked list only has efficient insertion and deletion at one end. However, a small modification keeping a pointer to the last node in addition to the first only will enable it to implement an efficient queue. A dequeue implemented using a modified dynamic array, queues and programming languages, queues may be implemented as a separate data type, or may be considered a special case of a double-ended queue and not implemented separately. For example, Perl and Ruby allow pushing and popping an array from both ends, so one can use push and shift functions to enqueue and dequeue a list, although in some cases these operations are not efficient. C++'s standard template library provides a queue templated class which is restricted to only push-pop operations. Since J2SE 5.0, Java's library contains a queue interface that specifies queue operations. Implementing classes include linked list and ArrayDec. PHP has an SPLQ class and third-party libraries like Beanstalk and Gearman. See also: circular buffer, dequeue, priority queue, queuing theory, stack the opposite of a queue, LIFO, references. Donald Knuth. The Art of Computer Programming, Volume 1, Fundamental Algorithms, 3rd edition. Addison Wesley, 1997. ISBN 0-201-89683-4. Section 2.2.1, Stacks, Queues, and Decks, ppA 238 to Euro 243. Thomas H. Corman, Charles E. Lesserson, Ronald L. Revest, and Clifford Stein. Introduction to Algorithms, 2nd edition. MIT Press and McGraw-Hill, 2001. ISBN 0-262-03293-7. Section 10.1 Stacks and Queues, ppA 200 to Euro 204. William Ford, William Top. Data Structures with C++ and STL, 2nd edition. Prentice Hall, 2002. ISBN 0-13-085850-1. Chapter 8, Queues and Priority Queues, ppA 386 a Euro 390. Adam Drozdek. Data Structures and Algorithms in C++, 3rd edition. Thomson Course Technology, 2005. ISBN 0-534-49182-0. Chapter 4, Stacks and Queues, ppA 137 a Euro 169. External links, Queue Data Structure and Algorithm, Queues with Algo and C Program, STL Quick Reference, VBSCRIPT Implementation of Stack, Queue, Deck, and Red-Black Tree, Paul E. Black, Bounded Queue with the NIST Dictionary of Algorithms and Data Structures.